So review of a pattern from last time. Take the sequence of numbers 1, 3, 6, and 10. So this pattern has come up before in the recordings, in the homework, in the book. And what I see here is to get from 1 to 3, I would add 2. To get from 3 to 6, I would add 3. To get from 6 to 10, I would add 4. And then I'm thinking, all right, I can continue that pattern. And then I can add 5 and keep on going. So I'm going to get 15, add 6. I'm going to get 21, and just keep moving on down there. Now, another way to look at this problem is geometrically. And one version of the geometry of this problem is to have what's called a figurative sequence, where we have one dot, and the next image we have 1, 2, 3 dots. In the next image, I have 1, 2, 3, 4, 5, 6 dots. So I'm making a triangle of the dots each time. If I put 4 on the bottom, 3 above that, 2 above that, and 1 above that, there's my 10 right there. So this is what's called a figurative sequence. The sequence above, because I don't have a constant difference here, it's not linear. So just quick note, this is not a linear sequence, since we're not increasing by the same amount each time, but there is a pattern to how this is increasing. We talked about the second row of differences. So 3 minus 2 is a +1, 4 minus 3 is a +1, 5 minus 4 is a +1. So there is a pattern to how the second row is increasing, which leads to how the original sequence is increasing there. Now, if I extend this moving on down here, so let's look at the next one, I would have 5, 4, 3, 2, 1. One way to look at coming up with that number is I just take the numbers 1 plus 2 plus 3 plus 4 plus 5 to get the fifth number in this list here. And in general, if I want to jump down and find a formula for the nth term, for the nth term formula, I want to add 1 plus 2, and I just want to keep going all the way till I get up to whatever number n is. All right, so for example, if n equals 100, then I need to add the first 100 whole numbers, 1 plus 2 plus 3, all the way up to 98, 99, 100. And whatever that sum is going to be the answer that I want. And we looked at a shortcut for this the other day, and there's a couple ways to go about it. I'm going to do it a little bit different than I did it in the last class. What I'm going to do is I'm just going to make the observation that if I take the first term and add it to the 100th term, that's going to give me 101. And if I take the second term and I add that to the second to the last term, that's going to give me another 101. And if I take the third term and add it to the 98th term, oops, I miswrote something, I'm going to get another 101. And so as I pair these up, first with last, second with second to last, I'm going to get a whole bunch of 101s. Now, think about what's happening in the middle of this list right here. We're going to count up, and in the middle here, we're going to see 50 and 51, right? And it keeps extending out to 98 and back to the 3 over here. So these two numbers are exactly in the middle. And if we add up 50 and 51, we're going to get 101. So the question, how many 101s were there in there? Well, because this was an even numbered list, there were exactly half of the 101s the way I was pairing things up, because every number had a pair to deal with. Now, that's not always going to happen. If it's an odd numbered list, it's going to work differently. So if I take my 100 and my 1 and add those up, that's where I got the first 101. And there are going to be 50 of those pairs here. That is going to be my sum, whatever 101 times 50 is. Which turns out that's going to be 5,050. We figured that out a different way last class. Another way to think about that, pairing up, when we pair things up like that, we can think about averaging. So the average value in this list would be the first term plus the last term divided by 2. Since everything's equally spaced, that's going to put me exactly in the middle. So that's going to be 101 over 2, which is going to be 50.5, right? 50 isn't the middle number, 51 isn't the middle number, but together they represent the middle. And so if we needed to pick a number between 1 and 100, it would be 50.5. That sits exactly in the middle there. Now that's the average value of all of these numbers in the list right here. And if you think about the idea of average from the perspective of some statistic you might have done in the past, to find the average of a group of numbers, you add them up, that's called the sum, and you divide by the count, how many numbers there are, okay? So let's just check this a slightly different way. I claim from the last 2 ways I did this problem that the sum of all those numbers, 1 through 100, was 5,050. So I believe the sum here is 5,050. How many numbers are in the list? Well, there are exactly 100 numbers in the list. Dividing by 100 is easy, you just shift the decimal point. So if I shift the decimal point 2 places, I get 50.5 for the average number. Now it turns out I can use this formula in a different direction. Instead of taking the standard way of looking at it and saying that average is the sum over the count, what I can do instead is solve for the sum. So I could rewrite this by multiplying the count to the other side. So I could say that if I take the average, multiply that by the count, that's going to give me the sum. And this is the sharing concept of the idea of average. If let's say there were 10 people in a class and everybody had some change in their pocket, and then we took everybody's change and threw it in a pot in the middle of the class, and we redistributed all of that change, and so that everybody got exactly the same amount, that amount would be the average that everybody got. Right? So the average is like an equal distribution of some amount. So I can either say average is the sum over the count, which also tells me average times the count is the sum. So if I happen to have an equally spaced list of numbers like I had a moment ago, let's pick a different one. Suppose I had 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, let's go up to 9. And I wanted to know what is that sum? Well, I could just take the average value, and a shortcut for the average, because these numbers are equally spaced. Sorry, that was messy there. Because these numbers here are equally spaced. They're all 1 apart. My claim is that the average of these numbers is the first term plus the last term divided by 2. 1 plus 9 is 10. Cut it in half, you get 5. And if we look at this list of numbers, we should be able to identify that 5 is the middle number. Oh. What did I do wrong? Did I miss a number? Oh yeah, I missed a number. I can't count. There should be a +8 right in there. And so I have 4 numbers to the right and I have 4 numbers to the left. 5 is the number in the middle. It's also the first plus the last divided by 2. And again, that works out nice because they're equally spaced. So that's a pretty important part of this right here. So I can look and get the average value of this really easy, first plus last over 2. Now, if I know how many numbers there are, I can just multiply by that, and that's going to give me the sum, is what this formula tells me here. So again, my average is 1 plus 9 divided by 2. There are clearly 9 numbers in the list because I counted from 1 to 9. So the sum should be 1 plus 9 is 10 divided by 2 is 5 times 9. It ought to be 45. So that's what these numbers add up to. That's kind of a third way to think about adding up equally spaced numbers. And it doesn't matter whether the spacing is 1 or if the spacing is 2 or 3 or 4, as long as all the numbers are the same space apart, one after the other, this is always going to work. So I'm going to show another example of that. So let's suppose I start with the numbers 1, 3, 5, 7. So here you can see I'm adding numbers up that are equally spaced. We'll even go one more, plus 9. So my claim that this sum right here is going to be the first term plus the last term divided by 2, right? That's the average value because they're equally spaced. And then if I multiply by the count, okay, now counting these is going to be a little trickier because they're missing some numbers, but I can see there are 5 numbers here. So there's my count. 1 plus 9 is 10, divided by 2 is 5. 5 times 5 equals 25. So this list of numbers should add up to 25, and we can double check that. The 1 plus the 9 here gives me a 10. 3 plus 7 gives me another 10, and then there's 5, and so I can check this does add up to 25. So this is kind of a shortcut to adding up a list of equally spaced numbers. And again, it doesn't matter how far apart they are. Now I want to extend that to another pattern you may have seen before.